So in this video we will discuss line of best fit. This video is relevant for QTAFC and ACC F2 students. We have discussed three things in correlation. I have uploaded 3 parts of correlation video. You must watch those before watching this video to get a clearer picture of what is going to happen in this video. First of all, I did discuss scatter diagram in my previous videos. Scatter diagram is a diagram in which we plot some data and develop a relationship between two variables. So now we will discuss a line of best fit. Let's say we have certain data which is x and y, and let's say x is the height of individuals and y is the weight. On the basis of correlations concepts, if you draw a scatter diagram plots these two variables, and let's have some random heights and weights. Let us assume that an individual who had a height of 60 was or had weight of 100. Let's say another individual had a height of 62 with weight of 110. Another individual had a height of 67 with weight of 125, and one more individual had a height of 68 and a weight of 135. Observing the data, we know that this is positively correlated. With an increase in values of x, there is an increase in values of y. Now if I plot these points on my scatter diagram, let's say this is 60, 100, the next one is 62 and 110, third one is 67 and 125, 67 and 125, let's say this one, and the fourth one is 68 and 135, 68 and 135, let's say somewhere over here. Let's add a couple of more values. Let's say we have 62 and 125 as well. 62 and 125 was somewhere over here, okay. And let's say one more value was 64 and 150, or let's say 140. Line of best fit is a line which is drawn for forecasting some more values using our previous results, these results. Well, my diagram may not be accurate because I am generally discussing the concept. The values and the numbers I have plotted, if you plot them on a graph properly, they may be different. Let's say I draw a line like this. A line of best fit is drawn to have or obtain a linear equation which we can use to predict our future values. This line of best fit is also known as least squares line. It is called so because let's discuss why did I drew my line like this to predict the future values. Let's say this distance, my observed value, and my line is d1. Let's label this distance as d2, this one as d3, this distance as d4, and this distance as d5, and this distance as d6. It is called least squares lines because if I value these deviations, let's say that this had some value which is 1, this had a value of 2, this had a value of let's say 1 again, this had a value of let's say 4 or any values. If I compute the distances and I obtain the values of these d square plus d2 square plus d3 square and so on, if I just add all the values squared up, my value of the sum of all deviations will be the least if I have drawn this line accurately, and I can use it to predict future values. This line is used to forecast the future information. Therefore, one more property for this line is that if I mark the distances below the line as negative, let's say -1, -2, and above this line as positives, +3, +4, all the sums of all deviations above and below, if the deviations below are given negative sign and above it are given positive signs, will sum up to 0. And I can use this line to predict some more values. Well, let us compare. Let's say I didn't drew this line, but instead I drew a line which was like this. Obviously, if you calculate the distances from all the individual points and square them up, the final answer will be much more greater, which is very obvious, than what we had over here. And obviously this line will not predict the values for futures accurately. Now the issue is, how do we compute the least squares line? I told you that least squares line is a line which has the minimum distance. If I value the distances below the line as negative and above the line as positive, or it is also called the least squares line because the deviations, the square of all deviations is minimum over here. So it is the best line to predict forecast values of future. How do we actually calculate that? To calculate the least squares line, let's say we have x and y axis. We use y is equals to a plus bx to obtain the linear equation for forecasting future values, and to calculate b we use n times summation of xy minus summation of x into summation of y over n times summation of x square minus summation of x whole square. And to calculate the value of a, we use summation of y over n minus b times summation of x over n. For example, let's say we had some data, and the data was, there were some x values, some y values. The x values were 1, 2, 4 and 6. The y values were 3, 6, 8 and 12. Our xy will be the multiplication, which is 3, 12 and then 32 and 72. Summation of x square, for summation of x square, our x square values will be 1, 4, 16 and 36. Y square values 9, 36, 64 and 144. So our summation of x will be 13. Summation of y will be 29. Summation of xy will be 119. Summation of x square will be 57. Summation of y square will be 253. And n is the number of pair of values 1, 2, 3 and 4. So our n is 4. Summation of x is 13. Summation of y is 29. Summation of xy is 119. Summation of x square is 57 and summation of y square is 253. Now if we calculate b, To calculate b, we know that b is n times summation of xy minus summation of x into summation of y over n times summation of x square minus summation of x whole square. So it will be 4 into 119 minus 13 into 29 over 4 into 57 minus 13 whole square. And if we solve it, it will be 4 into 119 is 476 minus 13 into 29 99 divided by 4 into 57 minus 13 square, which is 59, which comes out to be 99 over 59, and 99 over 59 is 1.67. Our a value will be summation of y, which is 57 over 4 minus 1.67, or b into summation of x, which is 13. Sorry, wait a minute. Our summation of y is actually 29. Summation of y is 29 over 4 minus 1.67 into 13 over 4. So our a value will be 29 over 4 is 7.25 minus 1.67 into 13 over 4, which is 1.8225. So our equation will be y is equals to 1.8225 plus 1.67x. Now we can use this y is equals to a plus bx, or y is equals to 1.8225 plus 1.67x to predict more values of y, given we have values of x with us. Thank you.